Okay, so we're still in 5.6, and we are in the land of non-right triangles. So, being from the place that we really, really like, which is right triangles, because then we get to use trig and Pythagorean theorem, we try to get every single triangle to come with us to the right triangle land, right? The reason why we want to go to right triangle land is, again, because then I have tools that I can use. I have the tool of trig, meaning sine, cosine, and tangent. I have the tool called Pythagorean theorem. I have no tools when it comes to non-right triangles, unless you read ahead like a couple of you did and you admitted it in the chat, which I like. But for that being said, the very first thing I'm going to do is I'm going to draw an altitude to one of these sides. Now, drawing an altitude to one of the sides means this. I'm going to draw a line that's perpendicular to one of the sides and goes through one of the vertices. So you can kind of see here, here's one altitude that I could draw, right? Here's another altitude I could draw, and here's another altitude I could draw. You're going to pick whichever altitude you want. I saw some of you picked this one, and that's fine. I tend to draw the one that's perpendicular to the base that's horizontal. I don't know why. It's just what my brain is used to seeing. So that's the one I'm going to draw. So I'm going to take my little, and it's going to be a little bit of a skill here. So there's my altitude, not drawn perfectly, and I'm going to call him H. I would normally call him A for altitude, or H for height. But since A is already taken up, I'm not going to do that. Okay, so from there, all I'm going to do now is figure out everything else. I just realized why I don't want to use this altitude. Did anybody realize why I can't use this altitude? Anybody see why I can't use this altitude? Mm-mm. Nice try, though. Yeah, very good. Because the only angle they gave me was this 35, and I'm like cutting him. Okay, so when I cut an angle, some of you want to say, like, oh, it split it in half. No, it didn't. Right? Can you imagine all of these like lines coming out of B? Right? They don't all, it doesn't necessarily mean that they cut it in half. So this one's not going to be a good one. So darn, my brain is going to have to think a little bit harder because it's going to have to like imagine. So then I go, okay, well, let me try this one. And I go this way. And so here, this maintains the 35-degree angle, which is good. And it has a B side, which is good. But in that triangle, I don't have two pieces of information, right? So over here, I have my 35 degrees. Over here, I have my B equals to 8. And no, clearly it does not cut that 13.8 in half. So again, this is not a good altitude to use. Does this make sense? So some of you are like, Miss Johnson, why didn't you just use the first altitude first? Because I don't want you to think that it's okay to use any altitude, I guess. All right, I'm going to try to draw this altitude. It's not the best altitude, but that's pretty good, right? So why is this altitude the only altitude I can actually use for this triangle right here? Yes, very good. In one right triangle, very good. Kind of. In one right triangle, I have two pieces of information. It's not about splitting anything because I remember over here, we split the C. That sounds funny. Like literally C. But here in one triangle, I need at least two pieces of information besides the 90 degree. I need at least two pieces of information. I either need two sides. I can have an angle in a side. Having two angles doesn't help me besides the 90 degree. That doesn't help me because I need a side. Okay, thank you for letting me know. I appreciate that. Okay. So from here, if you figured out, oh, let me use this altitude, I will now move forward. If you used another altitude and you used a different method, it would still come out with the same. You should still have the same exact answers as everybody else. Okay, so with that information, I have this right triangle, and I want you to train your eyes to only look at this right triangle. Over here, remember when we did this one, I separated them out for you to get your eyes used to looking at this. So I'm going to kind of keep them together so that your brain gets used to seeing this and almost like ignoring this guy right here and just focusing on my right triangle. Okay, with that being said, what do I know? Now that I have an altitude, what do I know? Now that I have an altitude, what do I know? It's okay to be like, I have no clue, Miss Johnson. You're putting something in front of me that's way harder. Okay, very good. So someone said the altitude is 8. This altitude here is 8. So I'm going to say no way. It can't be. Because in a right triangle, tell me about the hypotenuse. What do you know about the hypotenuse? What do you know about the hypotenuse? Good guess though. I like it. Don't feel bad. Like if you get something wrong, like trust me, I do something wrong all the time. You guys used to too. You guys used to do things wrong all the time. What, Ms. Johnson? You're gonna talk about me? Yeah. When you were little, you did wrong things all the time. And you just kind of moved on with your life. It was great. So I'm saying take that back. Do that again, right? Go back to the place where you do something wrong, you pick yourself up, and you're like, all right, I'm gonna move forward. Okay, so yeah, there's no way that C, I'm gonna make you the letter D. Oops, sorry, I erased everybody. CD, pretend this is this point right here is D. CD can be 8 if the hypotenuse is 8, right? The thing that you know about the hypotenuse of a right triangle, it is the longest side. No ties, there's no tying with the hypotenuse. If there's a tie with the hypotenuse, then most likely you're not in a right triangle. Because remember we talked about the bigger the angle, the longer the side opposite it, right? And if you're tied with a hypotenuse, either that means the angles opposite them are congruent, which means now you have two 90-degree angles, which if you've ever tried to draw a right triangle with two 90-degree angles, it doesn't exist, right? Okay, so nice try. I like it. Someone else said from B to C. So A, wait, what? So A equals 13.8. That's good. Someone else said 50. Angle C is 55 degrees. Okay, so this is a little bit ambiguous. Because I drew this altitude in, we can no longer call him angle C. Do you guys all remember that? Because when I say, hey, angle C is equal to blah, 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 how many angles are coming out of angle C? How many angles are coming out of angle C? Count them. Yeah, it's 3. There's 3 angles. Some of you are like, I see 2. So there's this guy here. So angle BCD. There's angle DCA. Where's the third angle? label it. So when we talk about angles back in the day, we will label them with 3 letters, and the middle letter has to be the vertex. So yeah, BCA is the third angle. BCA. So if you said it was ABC, no big deal, but look at ABC goes like this: A, B, C. So your middle letter is going to be the vertex of that angle. So when you're saying angle C is 55 degrees, do you want to correct your statement? When you're saying angle C is 55 degrees, do you want to correct your statement? Because I don't think you meant what you thought you meant. Who is 55 degrees? There's a bunch of you who said that. I missed what I said because now I'm barely really reading. That was when the timeout corner happened. I don't know what that was from. I'm sorry, I missed that. I tend to read our chats in order, in case you didn't know. Yeah, so what would you say instead of angle? So are you, okay, so we can't say, yeah. So we can say angle BCD is 55 degrees. So I can write that in there. Very good. What else do I know? Okay, so I think I found all the things without using either the Pythagorean theorem or the trig. So now I'm going to start using Pythagorean theorem or trig. Why can't I use the Pythagorean theorem here? Why can't I use the Pythagorean theorem here or yet? Why can't I use the Pythagorean theorem yet? Oh, I'm sorry. Someone said, hey, where did you get 55 from? Is that your favorite number? It's not my favorite number. Someone put it in the chat. Answer it, please. Yeah, very good. Not just to me, though. Someone said, hey, it's because in a triangle, not just a right triangle, in any triangle, the sum of the measures of the angles is always 180. So 180 minus 90 is 90, and 90 minus 35 is 55. Very good. Very, very good. When we get in trouble. Okay, got it. Okay, so then I'm going to have to start using Pythagorean theorem or trig, one of those two. Why can't I use Pythagorean theorem? Yeah, someone said because there's only one side in this right triangle, BCD. I only have no of one side. If you don't believe me, then write the Pythagorean theorem and it'll tell you. You'll say c squared plus h squared equals to 13.8 squared. So this is helpful if I knew what C or H are, but right now I don't. So this is not as helpful. So now I'm going to go to sine, cosine, or tangent. So this is where your preference goes. You guys all know my preference. You all know my favorite. So you're going to choose between sine, cosine, and tangent. I'm going to write a couple notes here while you guys choose which one you want to use. I'm going to scoot it over a tad. So for those of you who don't remember, you're going to either use sine, which is so, cosine, which is ka, or toa. Okay, so, ka, toa. I'm going to scoot you over a little bit more. Miss Johnson, does it matter which one you use? Kind of. I told you guys that sine is my favorite because 90% of them, 85% of the problems that you would need, you could solve with sine. I will tell you there's one of these that is useless to me. One of these is useless to me for this triangle, right? So which one did you use? Which one did you use? Put that in the chat. Oh, yes. Oh, wait, shoot. Did she already leave? Perseus, you're not in here, right? I don't see you. Okay. Which one? Okay, so a lot of people like sine. So, yeah, TOA is not helpful. Very good. TOA is not helpful, and the reason why is because no matter which angle you went from, either from 35 or from 55, it doesn't matter. TOA is not helpful because the opposite is H, adjacent is C. So he's not so helpful. I'm going to write that down though, because that helps me. So I'm going to go tangent of 35 degrees equals to H over C. And that's not even C, huh? Shoot, that's not C. We need to find another letter. Anybody know why this is not C? Anybody know why he's not C? Yeah, very good. C represents the whole side from B to A. So I'm just going to write X in here and Y, just so that I can remember to not use C. So I'm sorry, that's not right. So it should have been H over X. So again, I have an equation with two unknowns, not very helpful, unless I get another equation in there, but I'm pretty confident that there's one equation that'll go for both. A lot of people use sine. I like sine. I'm just going to tell you preference right now. My preference is always to use the information that they gave me the most first. So I'm not going to go from 55 because Miss Johnson, you've seen her. She makes mistakes over and over again. So if I use their information, most likely I didn't make a mistake on copying their material. So I'm going to go with sine of 35 degrees. I'm going to go sine 35 degrees equals 2. And then sine is opposite over hypotenuse. So you should have said it was H over 13.8. Hey, Ms. Johnson, can you say that again? Why is your preference to use 35 and not 55? So who found 55? Did they give it to you or did we find it? Right. Is there a small chance that you could have made a little error on finding 55? The answer is yeah. So Ms. Johnson knows herself very well, and I would prefer to use information that they gave me rather than the information that I found. Does that make sense? So I'm always going to go try to use their information, not mine. Okay. But every now and then I'm going to have to do it. Like in order to find all this stuff down here, I'm going to have to do it. So, so then I'm going to solve for H. For those of you who see this, if I am dividing by 13.8, so that must mean that to get rid of it, I will multiply by 13.8. Remember that we put 13.8 out all the way in the front of sine. So not to confuse us, are we taking the sine of 35 and then multiplying? Or are we multiplying and then taking the sine? So it looks like this. This may seem weird, but this sounds normal to me. 13.8 sine 35. Then I go over here to my handy dandy calculator, which I do not have open yet. So let me just grab it. So what's the very first thing I'm going to have to do with my handy dandy calculator? Anybody? What's the very first thing I should do on my handy dandy calculator? Very good. If you do not put it in degrees, you are going to be wrong. So watch. When I put 13.8 sine 35, this is the wrong answer. It doesn't even make sense. How could H, right, be negative? That doesn't make sense. Okay, so then you go over here, you hit the little degree symbol. Remember, Desmos is defaulted at radians. So I hit degrees and it automatically changes it. So I'll grab it to this one. So I'll say 7.915. So I'm going to say it's about. So I'll say H is equal to 13.8 sine 35 degrees. And then I'll say it's about, what did I say? 7.915? 7.915. So now that I know that H is this, right? I know H is 7.9135. So about 7.91. What did I say? 915? 915. Now I have choices, right? Yeah. Now I have choices. Right? I can use the Pythagorean theorem because he's my favorite, or I could just walk over to cosine and do that. You have choices now. If you know Mrs. Johnson, based on what she just talked about, what would she use? Pythagorean theorem or cosine or tangent? Pythagorean theorem, cosine, or tangent? Miss Johnson's using cosine. So when I write cosine, so I'm going to write cosine over here. I'll just write it right under. So I'm going to go cosine of 35 degrees equals to x over 13.8. So the reason why I'm going to use cosine and not Pythagorean theorem, which you can, I'm not saying don't use it, but I'm saying this is Miss Johnson's preference. So a lot of people don't understand that math, there's many ways to do it. And I just know my preferences. Like, I don't know, what do you prefer? Do you prefer brushing your teeth before you make your bed? Do you prefer making your bed before you brush your teeth? Do you prefer getting dressed and then cleaning your room? Like, what is your preference? So those are all preferences. Math has preferences. Miss Johnson's preference is to use all the numbers that they gave you, 35 and 13.8, 35 and 13.8, and not the numbers that she found, 7.915. So follow me. Let's pretend that I forgot to hit the degree button, and I'm like high into math mode. I'm like in it, and I'm like, yeah, that's negative 5.9. I don't even notice that this is negative. I'm so into it. And then I use it here to find me my, well, that's supposed to be x, to find my x, right? Now not only is h wrong, but now x is wrong. And then I bet you in a little bit, y is going to be wrong. And now everything is wrong. Does everybody see how that all works? So when I make a mistake here early on, and this is very classic, right? I don't know why I remember this, but my physics teacher used to always do this. He had like 3 questions on a test, except for one question was like part A, part B, part C, part D, part E, part F, right? So if you make a mistake on part A, crap, right? Crap. Because like now everything's wrong. But he would grade it so that if you made a mistake on part A and you used your wrong answer over and over again, it would be right based on your mistake as opposed to be just completely wrong. So do you see why my preference is to always use the numbers they give me rather than the numbers I find me? Yeah. And in my class, we would use these calculators, and the buttons were relatively small. And so if you had bigger fingers, like I have big fingers, if you had big fingers and you accidentally pushed 2 buttons instead of 1, like, dude, you were messed up, right? Okay, so this is why Miss Johnson would choose it, but could you use TOA? Absolutely. Could you use the Pythagorean theorem? Absolutely. Should you get the same exact answer? Exactly. So I'm going to actually prove that right now, so I'll show you. So of course we just say x is equal to 13.8 cosine 35 degrees, and whatever that is. So x is about something. So I'm going to bring this guy back. I'm going to be lazy, and I'm going to just type in cosine here. I'm going to remember to switch this back to degrees to make it right. So it's about 11.304. 11.304. So what I will do, I will use TOA and Pythagorean theorem to check my answers to make sure everybody makes sense, right? So I'm going to use tangent really quick. I'm going to say tangent of 35. Hey, what are you, right? And then according to this, oops, I never wrote you in there. So 11.304, right? So then I have opposite, which is 7.915. So 7.915 divided by 11.304, 4, not 5. And do you see how they're not exactly the same, but they're close enough to be like, yeah, that works, right? You can also check it using the Pythagorean theorem, which I will show you really quick. So that would be 11.304 squared plus 7.915 squared. That's 190. So then I'm hoping that 13.8 squared is 190. That's like, I'm hoping. Squared. Yeah, it's pretty close. So they're not going to be exactly equal because I'm never going to copy down all of the digits. In fact, this is not all the digits. The digits go on literally forever. So if I did capture all those digits, then they would be exactly the same, but I'm not going to do that. As long as they're in the neighborhood, I'm fine. So looking at this, what questions do you have for me? What part was hard? What part are you going to forget during your quiz or your test? Do you need to write a little flag to yourself? So Miss Johnson, how she takes notes, the part that she didn't think of that she relied on the teacher for, she would write a little flag like, I don't know, something like this, like, and I put, don't forget. So I'd write a little flag, I'd put it in a box, I'd highlight it, I'd do something, and I'd say, don't forget about blank. So here, if you didn't realize to draw an altitude, write that. Don't forget to draw an altitude. If you didn't understand why we couldn't use this first altitude I drew, then you need to write that. Like, ask her why we couldn't use that first altitude, right? If you were fine with the altitude, and then you, let's see, you didn't know which one to use between sine, cosine, and tangent. Like, Miss Johnson, why can't I use tangent? Why can't I use Pythagorean theorem at first? Write yourself a question, write yourself a don't forget, because there's a lot of things to observe here and there's details that you'll forget. So remember when I asked you this before, I said, okay, well, which part of this is difficult for you? And none of you said any of the parts were difficult. It was a matter of all of the steps to make sure that you were like completely right. So someone says, I know how to solve the equation, but I have trouble determining between cosine, sine, and tan. Okay, I have the fix for you. So if you struggle between using sine, cosine, or tangent first, by the way, I could have used cosine first, right? I could have found cosine first. There's no reason why I couldn't have done it. But if you know Miss Johnson, she likes sine, so she's going to try to use sine every single time. Okay. So my suggestion for you, if you're struggling between sine, cosine, and tangent, my suggestion is write all three out. Write all three of them out and be like, oh, I can use this one. Oh, I could use this one. Oh, I can't use this one. Because then it'll tell you, like, the reason why we can't use this one is because I don't know H and I don't know X. Or rather, I didn't know H and I didn't know X. Okay. So any other like, I forgot about this, Miss Johnson. Who forgot to switch their calculator to degree? Yeah. So if that's you, then you have to write here, don't forget to switch your calculator to degree. And then this little sticky note needs to show up on the very top of your homework. Don't forget to switch to degree, right? Which then needs to show up on the, the top of your test, right? So if we had physical paper tests, one of the things that I make people do before they even start the test is don't look at the rest of your test. Right now, draw your 30, 60, 90 and your 45, 45, 90. Go. And then I would let you take the rest of your test. And I make your 30, 60, 90 and your 45, 45, 90 part of your test. Here, unfortunately, this is the weird unfortunate. Because you have access to everything, it's open notes. I can make your test harder. Because now I don't have to cloud your brain with you memorizing 30, 60, 90, right? Okay, someone said, I also have trouble knowing which one's the adjacent, hypotenuse, and opposite of the triangle. So when you are drawing your right triangle, adjacent is always touching the angle. They share stuff. Do you see how opposite over here, the blue guy, does not share anything with the 35-degree angle? So the angle is actually this side, and this opening is called the angle here. But do you notice how this angle shares nothing with the opposite? But this shares a side with the angle. Does that make sense? It's one of the sides of the angle. The hypotenuse is always going to be across from, opposite of your 90-degree angle. Okay, always. So if you're having a hard time labeling opposite, adjacent, because then you can't even use sine, cosine, and tangent, right? If you can't do that, my first practice for you would be going through and saying, this is adjacent because it's next to him. This is opposite because he's across from him. Like, I don't know. This is weird, but I imagine this is the eyeball. Oh my gosh. Have I drawn this for you yet? No. Okay, wait. I need to draw this for you because then maybe this will make sense. So if this is your right triangle, right? Let's see, yeah. This is going to be weird, so sorry if this creeps you out, but I just think about this. I pretend that this is an eyeball. Do you guys all see my eyeball here? Hold on, wait for it. Boom. This is my eyeball. Yeah. So these are the fake lashes. These are the fake lashes. And it's looking at the opposite side. So this is what my brain, so I was also talking about this with my other class, like, how do you know how you learn? One of the weird things that I do when I'm learning something is I draw weirdo pictures to help my brain remember what is what. So for those of you who are having a hard time remembering which one's opposite, opposite is the one that my eyeball is facing. Like if me and you were playing chess, we don't sit next to each other. We sit across from each other so I can look at your eyeballs. I don't know why you sit across from each other when you play chess. If anybody knows, put it in the chat. But so it's the side that I'm looking at. Do you guys all see that? Okay, so hopefully this helps you see that this is opposite. It's my random little pictures that happen in my head. Now you know. Okay. So what's left of this? What's left of this is number one, I need to find angle A, and I can call him angle A. I can call him angle A because there's only one angle coming out of him, right? And I need to find this little section called Y. So now you're going to ignore this top triangle up here, the top right triangle up here, and you're only looking at the little bitty baby right triangle right here. In case you need to see the little right angle, he's in there, right there. Do you have enough information to find Y? Do you have enough information to find Y? Someone says, is this if we are given one angle? Plugged into the calculator. Yeah. I'll put it right here for you. It's right here. So someone said, can you show me ka just so that we see it? Yeah. Okay. So do we have enough information? Okay. So now your brain says, I'm going to start your brain all over. So I want your brain to think about it like this. Ooh, I have a right triangle. Yes. Here's the two paths that that we can go to solve this problem. What are the two paths? Very good. The Pythagorean theorem or trig. Some of you prefer the trig. Some of you prefer Pythagorean theorem. It doesn't matter. In the small baby right triangle, do you have enough information to use the Pythagorean theorem? In the small baby right triangle, do you have enough information? You do, right? What, Ms. Johnson, what do you mean by enough information? So in order for you to use the Pythagorean theorem, it's a squared plus b squared equals c squared, right? I need to know two sides to find the third. Here, I didn't have enough information because I knew one side, I didn't know two. So that's why I had to use sine, cosine, and tangent. Okay, so you're saying that I can use the Pythagorean theorem for my small baby right triangle? Answer is yes. Good. Just for fun, do you have enough information to use trig for your small baby triangle? Do you have enough information for you to use trig? Someone says, no. Very good. You don't, right? Actually, try it. Can everybody try writing, I don't know, use sine. Go use sine of A. Write sine of A and see if you have enough information to write it. Yeah. So sine of A is going to be equal to opposite. Look at your eyeball. Do you see your eyeball looking at that side? Do you see that? Does everybody see? Is that helpful? Was my eyeball drawing helpful? It creeps me out because it's such a big eyeball, I guess. I think that's why it creeps me out. Okay, so my eyeball's looking at side H. So that's going to be H, which is, I guess I shouldn't write H. I should write 7.915 divided by your hypotenuse. Which one's your hypotenuse in this one? Which one's your hypotenuse in this one? Yeah, it's 8. In case you didn't know why, it's because it's opposite of your 90-degree angle, right? So, the answer is yes. You have enough information to use sine, but what are you finding when you do this? What are you finding when you use sine? What's the only thing that's not a number? Your angle A, right? So I'm gonna focus on this really quick. You guys can find your Pythagorean theorem for y, but I do want to focus on this. Do you guys know how to solve this? We haven't talked about it in this class. Ideally, you would have talked about it last year, but I'm just not sure. Do you guys remember this? Yes. Okay. So the way you get, so some people think, oh, Ms. Johnson, do you just divide by sign? No. When you say you should divide by sign, that's like you saying we should divide by the square root symbol. No. Right. The way we get rid of sign is we use the inverse of sign. So what does that look like? It literally looks like what we used to talk about in the very first chapter. Sine inverse looks like this. Sine inverse. Okay. So normally before I would like try to squeeze them in, but because we have such awesome tech, we could just scoot them over and we can write sine inverse. Okay. So how do you type this into your calculator, Ms. Johnson? I will show you. So here we go here. So this is how you type it in. My calculator is already in degree mode, meaning it's going to spit out an angle in degrees. So when I'm plugging in tangent, this is giving me the ratio of sides like this, right? It gives me a ratio of sides. When I use sine inverse like this, it literally looks like this, right? And then you put 7.915 divided by 8. You get this angle 81 degrees. 81 degrees. So 81.64 degrees is your answer. Let me plug that back in over here. Let me take some of these guys. Oh, I want to leave that. So then we have A is equal, is about 81.64. Okay, so what I'm going to do is if I had like really tiny writing, I'd write it in there, but because I don't, I'm just going to write it like this. And then put that little symbol there, the little degree symbol, so everybody knows that you're measuring in degrees and that we're talking about the angle, so it makes it super clear. Okay, things that I know, okay? Yeah, right? So some of you plugged it in and you got a little bit of a different answer. You probably, I don't know, you didn't round, maybe you rounded to a little bit less. Maybe you just said 7.9 and then your decimal's a little bit off there. Don't worry about that. That's just a rounding error. You'll notice that I tend to grab at least 3, at least 2, because I want my answer to be a little bit more accurate. So then that way, when I'm grading your stuff, I know about where it should be. And then around there is where I accept answers. Okay. So when I look at 81.64 degrees, my brain says, that makes sense. Why does 81 degrees, relatively bigger angle, why does it make sense that this is 81 degrees? Where did I get the sine inverse from? Oh, okay. Back to here. So do you see how A is stuck in sine? Does everybody see how A is stuck in sine? Right? So if it was like squared, I would square root it, right? I would inverse it. If it was plus 4, I would subtract 4. I would inverse it, right? Because this is A stuck in sine, I need to inverse it. Sine inverse it, right? So sine inverse and sine cancel. So in case you don't believe me, let's show you. Let's find the sine inverse. Oops, wrong. Moving too fast. Okay, of sine of 45 degrees. Does everybody see what happens? Does everybody see what happens? What do you see happen there? What did you see happened? What happened right here? Yeah, right? They cancel out. Very good. They undo each other, right? So sine inverse is sine's inverse. I don't know how to say that better. I'll say it again. sine inverse undoes sine. Okay, that's better, right? So very much like, 3 times, let's do 3 times 4 divide, oh, that's not 3 times 4. Let's try that again. 3 times 4 divided by 3, right? What happened there? Well, multiplication and division, they cancel each other out. They undo each other. So that's true. Same thing goes for if I reverse those two. Same thing goes if I reverse those two. For example, let me just say sine of sine inverse of 0.47. I wanted to do something small. Right? So sine inverse, sine, they undo each other, just like multiplication and division and multiplication, they cancel each other out. They undo each other. Same thing goes. Okay. So I need to finish this problem. We've been doing one problem this whole time, guys. Woo. Okay, here we go. So last but not least, we need to find y, and then we need to find the rest of this angle so we can find this big angle here, right? So let's see. I'm going to erase my little don't forget thing so I have more room to write. Okay, so I would definitely use Pythagorean theorem for this, just to find it. So I would write, let's see, 7.915 plus y squared equals to 8 squared. So then that's y squared equals to 8 squared minus 7.915 squared, and then square root, right? And then don't forget to add plus or minus, but I'm going to ignore plus or minus for today because it just goes away. So 8 squared minus 7.915 squared. Okay, I did that kind of fast. You guys should be comfortable with that. Miss Johnson always likes plugging in one time to a calculator, not many, many times. So I'm going to write this out. So square root of, let's see, 8 squared, which I know is 64, but I like it better, 7.915 squared. So my answer supposedly is 1.1. Why does that make sense? Why does it make sense that that number is so teeny tiny? 1.163. Why does it make sense that that number is so teeny tiny? You're so funny. So I know that this is so teeny tiny because that angle looks teeny tiny, right? I knew this angle was going to be pretty close to 90. Anybody know why I thought that this angle was going to be pretty close to 90? Not exactly 90, but close to it. Does anybody see any evidence why it should be close to 90? Anybody see anything here? Yeah, very good. Because these two numbers are really close together. Very good. It's almost like this leg was trying to catch up to the hypotenuse, never going to catch up, but you understand what I'm saying. And because this ratio is really, really close to 1, that meant that this angle was going to be big. You'll learn more about how to guess these things. And like, you should be looking at your answer and saying like, 81 makes sense. Like if I got 7,000 for the height here, you all should be like, no, Miss Johnson, there's no way the height is this if the hypotenuse is that, right? You guys should look at your answers and be like, oh yeah, that makes sense. Okay, last but not least, I need to find this little tiny angle in here so I can find the big angle here. And that's just going to be 90 minus 81.64. So that's 8.36. So that's 8.36 degrees. This is like a mess. Look at this big old mess. So therefore, the big angle in there is going to be whatever 8.36 is plus 55. So what is that? 63.36. Okay, so I'm going to write that in there. I'm going to move my height for now because I don't need it. And I'm just going to go like this. This big angle here is 63.36 degrees. Okay, this is a mess. Normally when I'm doing math work, it doesn't look this messy. It's pretty organized. But because we had this like tiny little triangle in here, I was trying to shove them all in there. Normally I'll draw a bigger triangle and then so everybody could see everything. Let's see. So again, let's ask the same question. So which part of this here, yay, which part of this here is the part that is gonna snag you on the quiz or the test? So I'm going to say 90% of you are comfortable using Pythagorean theorem. That's kind of why I did it really quick. Okay. I'm going to say that a bunch of you are getting more comfortable with SOHCAHTOA. So person who said, Ms. Johnson, I'm getting a little confused with the opposite and adjacent. Did the eyeball thing help you? Did the eyeball thing help you? That's always helped me. For those of you who are like, oh, I don't know which one I should use, sine, cosine, or tangent, write all three down. Write all three down. Yeah, the eyeball helped you. Awesome. And then for those of you who saw this for the very first time, sine inverse, make this one of the ways that you tend to use. So then when you have to use it, you're not lost at it. Okay. Let's see. Ms. Johnson, could I have solved the tiny baby right triangle without the sine inverse sine? Not really. I mean, it would have been cosine inverse cosine, right? It would have been one of them. So if this is where you snag yourself with the sine inverse sine, just kind of remind yourself. So maybe you need a little post-it here that says, hey, to get rid of or to get A out of sine, use sine inverse. Okay. All right. So I'm going to pause this.